Now, groundwater, then we have the cost of drilling a well and developing that well so that it's ready to operate. Now, once we have the water supply available to us, then we have to get a pump and a power unit. And that's going to be an upfront initial cost. And that's generally going to be a pretty sizable cost of a given project. Now, we're just talking about buying the pump necessary and whatever power we're going to apply. In the Northwest, most of the time it's going to be electric motor. Power units going to be electric motor driven. But sometimes it makes sense to look at internal combustion engines. Depending on what part of the country you're in or the world that you're in, there may not be good power supply available. Or electricity may be very, very expensive. You go back in the East Coast and electricity might be as much as 10 times more expensive than it is here in Washington. And we have some areas in the state of Washington that have very, very low power rates. I mean, you go up to Grant County and they're in the penny and a half a kilowatt hour range. Go to Boston, Massachusetts, it's over 30 cents a kilowatt hour. So you can see the kind of changes that you might look at depending on what part of the country. And if you're irrigating in that part of the world, if you're over on the East Coast, you may look real hard at a diesel engine or natural gas engine to drive your power unit, because it'll only cost you about 6 to 8 cents a kilowatt hour versus the trade-off is once the kilowatt hours get more than about 6 or 8 cents a kilowatt hour, all of a sudden then the diesel engine or the natural gas engine becomes a very viable alternative. That's about the break-even point. With the price of diesel at $1 to $1.12 a gallon, somewhere in there, you're looking 6 to 8 cents a kilowatt hour is about where the trade-off comes for energy cost. So if your energy costs 15 cents a kilowatt hour electricity-wise, you're going to save money putting in an internal combustion engine. So you have to look at those possibilities. Another one, and we mentioned this earlier, in frost protection, where you need huge capabilities, mainly on orchards, and you'll see this happening here in the state of Washington. There are places that will have frost protection on orchards, and they have diesel engines to drive their pumps because of the demand cost just to run the electric motors. They might have to have 4 times the normal horsepower available, and they may not ever turn that pump on in a whole season, but they still have to pay a demand charge for this huge amount of horsepower just sitting there, because the power company charges you for power that is available, whether you use it or not. And there's a certain cost to that power company to run the lines to you, to put the transformers on the poles, and have the opportunity for it to be available. It's called an opportunity cost, cleverly, you know. Because it's there, it's available, it can be used, and it's an expense to all of the people that are involved in the utility. So you share the cost of and the burden by what you actually have available to be used. And it might be $5 a horsepower or $10 a horsepower just for the privilege of having it sit there. Well, if you had a 100 horsepower pump and it cost you $10 a horsepower a year just for it to sit there, that's a $1,000 bill a year that you pay whether it's used or not, right off the top. Every year you're going to pay $1,000. Well, how much can you afford to offset that $1,000, say, compared to a diesel engine? And then another thing they might do is, instead of even going out and buying a diesel engine, they might bring in a tractor with a PTO drive, something that they have on the farm anyhow, and it's basically a free power unit. It's just going to cost them the diesel to run the tractor during the hours that they're going to be doing frost protection, and use a PTO drive pump, and get the same job done that way with basically no initial cost. For the power unit, the pump is going to have an initial cost, but not the power unit, and no demand charge. So all it does is really cost them the fuel that they use during the frost protection cycle. So that's another option that a person can look at when they're designing systems that do require frost protection, because that is a real specialized, extremely expensive component to an irrigation system compared to just the basic watering system that you might use on the field.